Welcome back. Today we're going to be talking about proportions from tables and graphs, day number 2. Our content objective is students will be able to determine proportionality from tables and graphs. Language objective is students will be able to explain in words the reasons for proportionality from tables and graphs. Why am I learning this? Well, it's important for many real-life problems like finding the total cost given a unit rate and initial value. So let's go ahead and jump into our first example. It says, Peter is renting wave runners for a company party. Each wave runner holds 3 people. So if you're wondering what a wave runner is, here we go. This is what it looks like. Okay, so now that we know what it looks like, it says complete the table to show the relationship between the number of wave runners rented and the number of people that can ride. So here we have the number of wave runners and the number of riders. So if you don't have any wave runners, then you have, of course, no riders. Here, well, what if you have one wave runner? Then I would go ahead and say that it can hold 3 people, and I knew that from this information given here. So if I needed to hold 6 riders, I would obviously need 2 wave runners. And if I had 3 wave runners, well, since each one holds 3 people, I would go ahead and say that there would be 9 riders. Well, if I had 15 riders, then I would definitely need at 5 wave runners, and if I had 24 riders, I'm definitely going to need 8 of them, since again, each wave runner holds 3 people. So, does this scenario represent a proportional relationship? How do you know? I'm going to say yes. And why would I say yes? Because I'm noticing from 1 to 3, I'm multiplying 1 by 3. From 2 to 6, I have to multiply 2 by 3. From 3 to 9, I have to multiply 3 by 9, etc. And it happens throughout this entire table. So I'm going to say yes, and then that constant multiplier is 3. And we can see that by testing all of these numbers to see if it truly gives us this value here, which they do. So prove this, that it's a proportional relationship, by looking at the ratio of the output over the input. So the input would be the number of wave runners, and the output would be the number of riders. So if we set it up, first of all, note that we won't use 0, 0. So we would go straight to 3 over 1, 6 over 2, 9 over 3, 15 over 5, 24 over 8, and you're going to find all of them are 3. So how would we write this as an equation? We're going to get to that in a couple more slides. Now, to prove that this is a proportional relationship by graphing, I want to remind you that the key things we're looking for to prove that it's a proportional relationship is, number 1, it should be linear, meaning the graph is going to be a straight line, and 2, it should be going through the origin, the coordinate 0, 0. So the input, of course, would be the x-axis, which is the number of wave runners. The output would be the y-axis, which would be the number of riders. So if we took our table and we graphed it, you would find that our graph is indeed linear, aka a straight line, and it definitely does go through the origin, which further proves it is a proportional relationship. Also, the same way going backwards, if from your table you know it's a proportional relationship, you can figure out what that constant multiplier is, then when you graph it, you should expect to see a straight line that goes straight through the origin. But wait, there's something that we have to talk about. Depending on the scenario, a line may not be drawn through the ordered pairs. You'll notice the line has been removed. Why? Because in a case like this, it doesn't make sense to draw a line. Because if we did, this line here would indicate that for, let's see, 1/2 of a wave runner would mean that it would hold 1.5 people, which, first of all, we're not going to have half a wave runner, nor should we have 1.5 people. So this would not be connected. So you would end up with points by themselves. However, if it still does go through the origin, does it mean it's still proportional? Absolutely. The fact remains that these points, if connected, they would still be linear, and it does go through the origin. So just keep in mind that in certain cases, we don't necessarily draw the line through all the ordered pairs. So what is the constant of proportionality? The answer is 3. We found that every single time you'd have to multiply the number of the number of wave runners by 3 to figure out how many people it can hold. What is the unit rate? The unit rate is 3 riders per wave runner. And the reason why we got that is when we set it up as output over input, if you left the units on, for example, the first one would have been 3 riders per 1 wave runner. So if you're not sure how the units are going to go, definitely write them down, and that would guide you to what your answer should be. Now, there are several ways you can find the unit rate. One way is simply by looking at the constant multiplier, aka the constant of proportionality. Another way is to look at the table. You would have seen in the table, it said that for 1 wave runner, it can hold 3 riders. So it could definitely be seen in a table by itself. And now another way would be in the graph. Specifically looking for 1 wave runner, you're going to see that it's going to hold 3 people. So there are 3 ways to find it. Number 1, looking at the constant multiplier, aka the constant proportionality. 2, looking at the table, looking specifically for when the input is 1. And then, of course, also looking at a graph, specifically looking for when your input is 1 as well. F. What is the significance of the point 0, 0? 0, 0 is the initial value. It's what you start with. In this case, it means that for 0 wave runners, you have 0 passengers or 0 riders. But it can also be considered the starting point. Same idea. Now let's look at G. It says write an equation expressing the number of riders R in terms of the number of wave runners W. Where do you see the unit rate proportional constant in this equation? So let's think about it. We know that each wave runner can hold 3 passengers. So if I want to figure out the number of riders R, I'm going to have to take the number of wave runners and multiply it by the 3 passengers that it can hold. So here, to simplify this, because I wouldn't write it as R equals W plus 3, I would say R equals 3W. Now to answer the second part of the question, it says what is the proportional constant? I would go ahead and say the proportional constant is, of course, 3, which can also be referred to as the unit rate. Now H, it says determine how many wave runners Peter needs to rent if there will be 51 people at his company party that all want to ride a wave runner. So as you can see here, first what we're going to do is utilize the equation we just built. Remember that R represents the number of riders and W represents the number of wave runners. So here, since they're wanting to know the number of wave runners, we're going to need to figure out what W is. And here, since it's 51 people, those are considered riders. So I'm going to go ahead and plug that in for R. So let's go ahead and do that. I'm going to go ahead and replace R with the 51, and that should equal 3 times W. To solve for W, aka the number of wave runners we're going to need, we're going to have to divide both sides by 3, which is going to leave us with 17 equals W. So how many wave runners will we need? We will need 17. So Peter must rent 17 wave runners for his 51 employees. Okay, so moving on to another example. It says here, Sunset Splash and Spa charges an entrance fee of $5 and then $2 per hour. Complete the table and graph to represent the situation. Be sure to label the axes of your graph. So here this table is in T in times and C for the cost in dollars. So you'll notice here, since they do charge an entrance fee of $5, even if you had no time at the spa at all, you'd be charged the $5. But on top of that, you are going to be charged $2 per hour. So you'll see here, for 0 time, you're still charged $5. So for 1 hour, first you're charged that $5, but on top of that, the $2 for the hour you're there. So that's going to be 7. For 2 hours, once again, you're going to be charged the $5 plus a 2 for 1 hour and another 2 for 2 hours. So that's going to be 9. For 3, you're going to, of course, be charged the $5 for the entrance fee, and then we're going to add 2 3 times to consider the $2 an hour, which is going to give us $11. And for 4, you're going to hopefully start seeing a pattern. The entrance fee plus the $2 an hour. Now you're noticing it's getting a little tedious. So is there a quicker way to write this? Well, here, instead of adding a bunch of 2's, I can say, hey, you're charged the $5 entrance fee. And since you're going to be there for 2 hours, I'm going to add 2 5 times. And a quicker way to write that would have just been to do 2 times 5, which would give me 15. So again, you could have also written this as 5 plus 2 times 4, since you have to multiply that 4 times. Here, it could have been written as 5 plus 2 times the 3 hours, so we're going to add 2 3 times. And here, we're going to add 2 2 times, so you could just do 2 times 2. And this one would just be 2 times 1. So hopefully you're starting to see a pattern. So now that the table has been filled out, let's go ahead and fill out the graph. Just keep a reminder that your input would be the x-axis and the output would be the y-axis. Let's go ahead and label the increments and fill out the graph. So you'll notice here, this is what the graph is going to look like. Definitely is linear, but we notice a problem here. It does not go through the origin. Now another thing I want you to keep in mind is, do you notice any constant multiplier that can get from 0 to 5, from 1 to 7, from 2 to 9, from 3 to 11, from 4 to 13, or from 5 to 15? Hopefully your answer was no. So to answer part B, it says, are the cost and time proportionally related in this situation? Justify your answer using information from your table and graph. So the answer is no. They are not proportionally related. Why? Well, from the table, there is no constant multiplier, and the ratios of output to input are not equivalent. And from the graph, even though the graph is linear, it does not go through the origin, so it's not a proportional relationship. So C, while there is not a proportional equation that will represent the situation, there is an equation that will represent it. Can you find it using T for time and C for cost? Well, first of all, we're going to figure out the cost. How? We notice that in order to do that, we would always have to do the $5 entrance fee, and on top of that, we were charged $2 for every hour. So 2 times C, in this case, T for time. Now you're going to find later down the road that this is equation, but we typically write the coefficient in front of the constant. So a better way to write this would be 2t plus 5. So they are the same, however, again, you typically write your coefficient first before your constant. So this is our equation. So you're going to notice here, in comparison to the previous equation, this one looks slightly different. The previous one was the riders is determined by 3 times the amount of wave runners. So you'll notice this one has a constant of 5, and this one doesn't really have a constant. You can think of it as 0, and this indicates the origin, that it will pass through the origin, that for 0 wave runners, 0 riders. Here, you'll notice even for 0 hours, you're still charged $5. So that is the main difference between these two. Now, based on the equation you found in part C, what is the total cost for 29 hours? So for 29 hours, is that a cost or is that time? Definitely going to go with time. So I'm going to go ahead and utilize this equation. C equals 2. Instead of a T, I'm going to go ahead and put my 29 hours, because that is time, and add 5 to that. So the cost is going to be 2 times 29, which is 58. If you add 5 to that, the cost C is going to equal 63. So it would cost $63 for 29 hours. Hopefully you're not at a spa that long, but if you were, that's how much it would cost. Okay, for number 3, different problem here. It says Juan is renting canoes for a family reunion. Each canoe holds 4 people. Complete the table to show the relationship between the number of canoes rented and the number of people that can ride. Go ahead and pause the video and try this one by yourself. Okay, so let's go ahead and go over the answers. I'm going to go ahead and quickly go over the answers, so please check to make sure that yours are correct. So here for 0 canoes, of course, there would be 0 riders. For 1 canoe, there would be 4 people. Why? Because each canoe can hold 4 people. If you needed 8 riders, you would need 2 canoes. If you had 3 canoes, you can, of course, with 4 people each, is going to allow you to seat 12 people. Now, if you had 20 riders, you would need 5 canoes. If you had 32 riders, you would need 8 canoes. So, does this scenario represent a proportional relationship? How do you know? The answer is yes, because there's a constant multiplier of 4. I can show you. 0 times 4 is 0. 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 5 times 4 is 20. And 8 times 4 is 32. Let's prove it by checking the ratios, output over input. Let's remind ourselves the canoes is input, the riders is the output. So of course we're going to leave off 0 over 0 because that is undefined. So we're going to do 4 over 1, 8 over 2, 12 over 3, 20 over 5, 32 over 8, and you're going to find all of them equal 4. So we're going to go ahead and prove it's a proportional relationship by graphing, which means we expect it to be linear. We expect it to go through the origin. Since the input is the number of canoes, that's our x-axis, and since the output is the number of riders, that is our y-axis. Simply plot all the points and you will find that it is linear and it does go through the origin. But notice again here, we left off the points. Why? Because in this case, you can't have half a canoe. Okay, you're definitely not going to have half of a rider. So for those reasons, we are going to leave them as separate points that are not connected. But is it still proportional? Absolutely, because it's still linear and it still goes to the origin. That if for 0 canoes, you should have 0 riders. So what is the constant of proportionality? It is 4. And what is the unit rate? List 3 different places you can find it in the problem. Well, it is 4 riders per canoe. It can be found by looking at the constant multiplier, which we saw from the table. And it can be found in the table when you specifically look for 1 canoe. In this case, it was for 4 riders. And you can also look at the graph, which in this case is 1, 4. Specifically, whenever you're looking at the table or whenever you're looking at the graph, you're looking to see when the input, aka x value, is 1. So what is the significance of 0, 0? As a reminder, remember it is the initial value or the starting point. In this case, for 0 canoes, there would be 0 riders. Now it says here, G, write an equation expressing the number of riders R in terms of the number of canoes C. Where do you see the unit rate, proportional constant, in this equation? So, the number of riders can be determined by simply multiplying the number of canoes by 4. Why 4? Because each canoe can hold 4 people. So here I would simplify that to just R is 4C, because we typically write the number before the variable. And to answer the question some more, where is the unit rate? It can be found right here. Here is your unit rate, aka the proportional constant. This is what we multiply to determine how many people can be held in a specific amount of canoes. Determine how many canoes Juan needs to rent if there will be 76 people at the family reunion that would want to ride a canoe. So let's go ahead and utilize the equation we just created. Here, 76 people is definitely representing the number of riders. Okay, so I'm going to go ahead and plug that for R. So we're going to put 76 for R, and we're going to solve for C, since C is the number of canoes, which they definitely are asking us to figure out. So we're going to divide both sides by 4, which is going to leave us with 19. So to answer the question, C, if C represents the number of canoes, how many canoes would be needed to seat 76 people? The answer would be 19. So Juan needs to rent 18 canoes for the 76 people at the family reunion. Guess what? That concludes the lesson for today. Thank you so much for tuning in, and as always, until next time, bye.